Good afternoon, Algebra 2 students. Let's take a look today at lesson 76. If you get a chance to see the video before we meet, that's great. Then you already know today's concept. If not, and you're already if you've already started on your lesson problems, that's fine. You can watch this for homework and finish up those couple of problems that pertain to this concept. You can do that at home, and that's not a problem. Okay, but I do want to meet with you on Zoom today for a little bit. So I will see you there in just a bit. But let me go ahead and get today's lesson out to you. So we're going to discuss two different things today. First, we're going to talk about systems of equations. Let me get a blank sheet of paper here. Okay, so something that we've already been doing, if you can think back with me, we're going to recall this information. We've learned how to do systems of equations where we have two equations in here, something like this, 3x plus 2y equals 8. And x plus 3y equals a negative 2. Okay, and we can use either substitution or we can use elimination, right? So we could multiply the second equation by negative 3, all of our terms. Oops, come back here. Right, we could multiply everything by negative 3 because that would eliminate this, or we could actually use substitution if we wanted to. We could actually take the second equation and set it up so that it's x equals negative 3y minus 2, something like that. And we could substitute in this value for x. Okay, so we've learned to do both of those ways where we substitute or we eliminate. However, when we solve a system of three equations with three unknowns, it can be helpful to begin with substitution and then finish with elimination. Okay, so we're going to see a problem like that. So let me do one for you as an example, and then we're going to build one into your notes. Okay, let's say we have this system of equations. There's three of them here. So x equals 2y, and we have x plus y plus z equals 9, and we have x minus 3y minus 2z is equal to negative 8. Okay, and I'm going to just kind of assign letters to these. So we have equation A, B, and C. Okay, so the first thing we're going to do, so remember I said it's helpful if we can begin with substitution and then end with elimination. I'm just abbreviating those, okay? Excuse me. So let's start this process. So the first thing I want to do is I'm going to pull down my second equation. And the reason I'm going to choose the second equation is because I can actually take my first equation and substitute it in for x. So let's watch this. So I've got equation B right here. Okay, and off to the side here, I'm going to substitute equation A into equation B. So look at equation A. Equation A up here, let's get yellow, is x equals 2y. So where I see y, I'm going to substitute in, where I see x, sorry about that, I'm going to substitute in 2y. So let's go ahead and do that. So I'm going to put 2y plus z equals 9. Okay? Now, I'm going to come down here and I'm going to put down c because I'm going to do the same thing for c that I just did for b. So we have x minus 3y minus 2z equals negative 8. And if I substitute in my x value as 2y, it's going to look like this. Okay, now I'm going to go ahead and put together my like terms. So I have 2y plus y, which is going to give me 3y plus z equals 9. And here, I'm going to have negative y, because I'm going to add together these like terms right here, right? Minus 2z equals a negative 8. Okay, so here's what I'm left with here, and I'm not done yet. Make sure you see that negative there. So the next thing I'm going to do is I'm going to take those two equations. Let me just put this is just going to be step 2 right here. We'll call this step 1 up here. So step 2, I'm going to take these two equations and bring them over here. 3y plus z equals 9, and negative y minus 2z equals negative 8. Okay, now I've done my substituting. Now I'm going to do my elimination. Remember we said up here, Let me put a different color around this. Up here, first we substitute, which is what we did in step 1. Now we're going to eliminate. So in order to eliminate, I have to change something with one of my variables so that I can eliminate it. Well, the easiest one that I see is I'm just going to multiply this first equation by 2 all the way across, right? And what's that going to give me? I'm going to end up with 6y plus 2z equals 18. We'll leave this one as is, negative y minus 2z. So you can see here, we're going to eliminate our z terms, minus 8. We'll put these together. We'll eliminate those z terms. I have 5y equals 10. We solve this through. We're going to end up finding out that y is equal to 2. So there's my first one. Okay, now how do I get my next 2? Well, I'm going to go back now. I'm going to grab step 3 here. We're going to solve for x. I'm going to take the easiest of the equations. I'm going to pull a down here. Equation a, which is x equals 2y, because that's going to allow me to solve for x right away. So x equals 2 times 2, because we said y is equal to 2, right? So x then is equal to 4. That was easy. And then step 4, we're going to solve for the last variable that we have, which is z, and I'm going to grab equation b. So look at b, easy peasy. X plus y plus z equals 9. We know 2 of those, we just need to find the third. So we have x plus y plus z equals 9. We have x is 4, y is 2, plus z equals 9. And to solve this all the way through using every step, you're going to have z equals 3. So there's the value of each one of our variables. So how do I write this as an answer? We write it like this, where we're going to have x, y, and z. We have 4, 2, and 3, and that is the answer to that problem. Okay, so we've been doing these systems of equations. Now we're just doing it with 3 systems rather than 2. So in your notes, let's go ahead and build one in there. Let me go back up here. All right, here we are in letter A, substitution and elimination. Let's go ahead and do one of these together. So we're going to name each one of these A, B, and C, and you're going to write this into your notes. Okay, and the first thing we're going to do is we're going to substitute. But we have to pull 2 equations down in order to do that. So let's substitute. We're going to pull down A, and we're going to pull down B, but I see a problem up here. How am I going to substitute something? I don't have any one of these equations that are set up to substitute, but if you notice in C, look at equation C. I'm going to change this around. I'm going to set it equal to x. So if I move 3z to the other side, I add it to both sides, I'm going to end up with x equals 3z. Now I have a value for x that I can substitute into both equation A and B. So let's write equation A, and let's write equation B. Actually, we're going to put B beside it. Let me move this B out of here because I'm going to use the bottom. I'm going to, underneath that, finish this up. Okay, so we have x, we said, is going to be equal to 3z. So let's put 3z in for x plus 2y minus z equals 12. So we're going to end up combining our z terms. And we'll end up with an equation that gives us 2 variables like we're used to. So we're going to have 5z plus 2y equals 12. Okay, so there's the first equation we're going to be using. Okay, so we substituted. We're going to substitute here again. I'm going to call this step 1 because this is still part of the first step. So we're substituting again into the next equation, B. 3x minus y plus 2z equals 21. Let's put in what we said x is. X is 3z. We're going to substitute that in. You see, again, we're going to end up with 2 variables. So we have 9z minus y plus 2z equals 21. Put our z terms together. We're going to have 11z minus y equals 21. Okay, so there's our second equation. We're going to be using that here. I'm going to make a little room over here, our step 2. Oops, hang on a second. Drop something here. Okay, step 2, right up here. Step 2, we're going to eliminate. Because remember, first we substitute and then we eliminate. These are in the proper order right up here, up by letter A, in the order you're going to do them, substitute and eliminate. Okay, so let's take our equation. Again, we're going to choose to use this new one that's down here, this 5z plus 2y equals 12. And we're going to write below it the other one that we just came up with on B, 11z minus y equals 21. Okay, so here's our system now. We want to eliminate one of these variables. What looks easiest to me is to eliminate the y variable. So we're going to multiply all of this by 2. I ran out of room over here, I think. I have to write small. Okay, so we're going to have 5z plus 2y equals 12. And here, if everything gets multiplied by 2, you're going to have 22z minus 2y equals 42. We can eliminate our y terms here. Oops. Yeah, okay, I'm good. And now we're going to have 27z equals 54. And if you divide both sides by 27, you plug that in your calculator, you're going to end up with 2. Z equals 2. So there's our first variable we've solved for. Number 3, and this is going to get a little messy, I think, for me. It looks a little better on my packet, but I'm trying here. So now we're going to substitute into C. So let's pull that C equation down from our original equations, write it as it was given, and we'll substitute in our Z variable. So x minus 3 times 2 equals 0. And x is going to equal, well, we'll write it out. X is going to be equal to 6. So there's my x variable. And then number 4, we're going to substitute again, but this time we'll substitute into either one of the other ones. I'm just going to pick A because the numbers are smaller. Why complicate things more? So we're going to take 2x plus 2y minus z equals 12. And we're going to now plug in our x and z values. So we have 2 times 6 plus 2y. So we're going to solve for y here. Minus 2 equals 12. 12 plus 2y minus 2 equals 12. And I'm going to move it over just a little bit here. So we have 12 minus 2, right? So we have 10 plus 2y equals 12. Subtract 10. 2y equals 2. And y equals 1. So how do we write this answer? So up top here, where's my best place? I'll do it right here. I'm going to do it in a different color so it shows up and you can see it well. The answer, we're going to write these in alphabetical order. So we would go x, y, and z. So x is 6, y is 1, and z is 2. And that's the answer. Okay, a lot of work, right, just to find those 3 variables. But in a system like this, it's nice because then it works out rather well. Okay, that sums up, let's see how many minutes I'm in. I'm going to go ahead, I'm going to make 2 videos for you. Okay, I'm going to make one for this first part so you can watch this and get started on the lesson with that new concept. I'm going to go create another video for the second part of this. All right, so thanks for watching the first part. I'll be back shortly.